I'm Ned Pelger of ConstructionKnowledge.net, a website focused on helping construction supervisors connect, learn, and advance. When I'm on this job site during earthwork phase, I often stop and pick up some dirt and squeeze it into a ball, roll it into a thread, and generally just get my hands dirty. I don't do this just so my wife sees my hands and finds me rugged and virile, although of course that's a side benefit. I'm trying to understand and classify what type of soil do we actually have on the site. So why do I roll the dirt in my hands? Why do I care about the soils? Well, soils vary widely even on one site. There are lots of problems that come from soils: trench cave-ins, muddy site conditions, dusty site conditions, settlement of structures, sediment of soil backfill. The competent construction supervisor understands if the site is clay, silt, sand, or gravel, or what combination thereof, and further understands how that soil affects the project risks and decisions. I remember as a young man we had a trench cave-in a project, and 19-year-old Clint Bachman was killed in that cave-in. And I wanted to understand soils before that, and I wanted to understand soils even more after that. And I've continued to always take an interest in the soils and the projects that I'm working on. So why should you care about soil compaction proctor tests? Well, one, to avoid looking stupid. Say you're on a site and the soil tests over 100%. You laugh and say, "Oh, that's impossible, it couldn't test over 100%. The people that understand how a proctor test works know that you don't. And I've found it's best not to look like a fool, at least not too many times in one day. Okay, let's get into the details, the proctor test basics. Soil sample is taken in the field by the testing lab and then tested in a certified lab. Soil sample is dried, divided into several different samples, and then water is added to each sample. So we get a different moisture content for each sample. Then those samples are made more dense by dropping a weight. It's a 5.5 pound weight that drops about 20 times from a height of 12 inches. So that's how each one of these samples is made more dense. Then the lab measures that density and puts it on a chart. The horizontal axis shows the percent moisture content, and the vertical axis shows the dry density in pounds per cubic foot. As you can see in the example here, the 4 soil samples shown on the chart get more dense as the moisture is added, up to a high point, and then the moisture makes them less dense. Does this make sense to you? Well, now think about dust and mud. If you're trying to compact dust, you just can't get much compaction. As you get to the right amount of moisture added, the soil can compact well, but then when you get to too much moisture, it turns into mud. So it should make sense that you get kind of a line that connects those dots. The maximum in that line is the highest compacted density. In this example, it's 120 pounds per cubic foot. Then the optimal moisture content is found by just coming straight down from that maximum density, and here it's shown at 15% moisture content. So if the specs call for 95% compaction, that would be found by taking the 120 pounds per cubic foot, multiplying by 0.95, and that gives you the 114 pounds per cubic foot that shows the horizontal line across there. Then the upper and lower limits of moisture are found by just finding where that horizontal line intersects the density curve. Okay, so what does it help a construction supervisor to understand this test? Well, how many times has soil compaction been a problem on your project? Probably fairly often. It has been on mine. If the construction supervisor owns the schedule, then that construction supervisor also owns the soil compaction problem. So you've got a problem, what things could you recommend? Well, to start you could say, well, maybe the soil sample's wrong. You can go to the lab and say, I'd like another proctor test done on another type of soil here because I think it's a different soil. You could talk with them about whether the moisture limits aren't quite right. You could find that maybe you can overcompact it to 100%. As we talked about earlier, you can densify it more in the field. It could just be a lab mistake. If you understand the tests and you know what you're looking at in the field, you just make better decisions. So the takeaway from this is when you know how the proctor test works, you know how to work with it. To conclude, remember to take time and understand the technical side of this amazing construction business. You will see how it benefits your career. I hope you found this short video helpful. For more resources, please visit ConstructionKnowledge.net. Thank you.